Welcome back to another episode of Rennch. On today's show, we are going to begin one of the techno mods that I've been thinking about doing to this car for the last 3 years. Welcome. If you are unfamiliar with this project, this is a 1969 Porsche 911S that was a race car. I've converted it back to a street car, and it's powered by a twin-turbo Subaru EZ30R flat 6. Now, that engine is powered by a Haltech Elite 2500, which has CAN bus, which is a digital communication platform to tell us what's going on with the inside of our engine. Now, you may have heard me call this a techno mod. What I mean by that is, my idea for this build was if it comes on like a 2024, 2025, some futuristic car, and I can integrate it invisibly into the build, I'm gonna do it. And that involves all kinds of cool sensors and cameras and things like that. Today's show is about the first of one of those cool projects. All right, so this is the TAC. This is the big gauge on every single Porsche. It's right in the middle. It's like a big 5-inch almost gauge, and it is flanked by 2 gauges on the outside, and they are the miles per hour, and then we've got oil temperature, oil pressure, and we got a battery light here. These are great. These are the original analog gauges for this car. However, I got a lot more stuff going on this engine. I've got cameras, I've got all kinds of technology all around the car, and I want to be able to display what's going on internally and externally with the car. So in my vision, if I put my turn signal on, it would be really cool if I could have a visual of what's going on that side of the car. Or if I put the car in reverse, it'd be cool to see what's going on behind me like modern cars do. So what I've done is I found these LCD panels. I've got a 5-inch and I've got 2 4-inch panels here. So we're going to use a little Sencut Sen. We're going to use a little Raise 3D. We're going to use a Raspberry Pi and connect all of that stuff to CAN bus. At the very least, what I'll do is I'll design these gauges to look exactly like the vintage gauges, but they'll be the digital versions of them. So when you turn the car on, they're going to look like standard gauges. However, I've got twin turbos, I've got boost pressure, I've got all kinds of cool things that I'm monitoring on the engine. So I want to be able to integrate that stuff into what will now become a new digital gauge. I have no idea how I'm going to do this. What I do know though is I have these are basically like little monitors. These are basically computer monitors. They come with their own little HDMI breakout box. And somehow I have to integrate these into some little computer that I'm going to make a mount for. So what I'd like to accomplish today is I'd like to see if I could cut this thing down to some sort of size and get these things kind of mounted, even if I tape them up on the back side of it, and get them kind of in place on the car just to see where I'm at, see how I'm going to actually be able to pull this thing off. What I think is going to happen is I'll probably have to do some sort of 3D printed bezel. I've got to solve how I'm going to get these outer rings and the glass and then have these little screens behind. So these things just basically cover the stock size, so I think they're going to work. I just don't exactly know how I'm going to manage. I'll probably have a metal piece and a 3D printed piece and figure out some way to get these 3 things mounted in the proper holes, and then figure out how to build like a little computer behind it, and then figure out how to program everything, and then figure out how to connect it all to CAN bus and all that. So we are very early in this process, but using this plexiglass and these things, I'd like to figure out how the heck to pull this off. One of the cool things about working with clear plexi is you can, obviously see what you're doing and just cut around while still seeing the stuff on the other side. So that's why I'm using this. Now that I have my holes marked, I don't have a great way to cut them. Obviously, I'll do this through Send Cut Send. I will measure these things out and get exact dimensions. So this thing will be laser cut out of metal, probably. And that'll be obviously a little bit better, or I'll 3D print it, we'll see. But for now, I'm gonna drill a bunch of holes and maybe use this air saw to see if I can like cut a ring around. All right, so this is, I mean, terribly cut, but it doesn't really matter. This is sort of proof of concept to make sure this thing kind of works. I'm gonna peel off the outer layer here. I'm gonna try to tape the pieces on and then try to get them in there and see kind of how they look. And then figure out what my next steps are in terms of like getting the stuff custom made from Send Cut Send. All right, here's a first look at the digital gauges. So the reason I did the 3 separate monitors is because this whole piece curves like this. There's 2 issues. Number 1, there's not a screen that's big enough to go to the outside of this, and then also it would have to curve. So this is 3 separate HDMI powered LCD screens. You can obviously see I still need to trim some plexiglass there, but again, this whole thing is going to be metal. So what I'll do is I'll have Send Cut Send use their water jets or whatever they do, laser, and cut me a piece that's a little bigger than each one of these holes. So this thing's on the back side, and I'll do probably some sort of 3D printed cradle or something. I don't know yet. I have to figure out how it all fits together, but proof of concept. Each one of these is going to be a vent for the classic retrofit air conditioner, and I may end up putting something down there as well for a 3rd vent. But proof of concept, this thing looks awesome, and I can't wait to see how it finishes up. Now, because I want to see this super clean, I'm gonna trim these pieces a little bit and remount this and see how it looks. All right, here we go. This looks awesome. Now I gotta make it do something. Definitely proof of concept here. I had to modify my framework a lot, actually. And the most important part is now I can take measurements from the inner plexiglass part to the body of the car and start figuring out how I'm gonna mount this thing, which is not gonna be probably the easiest thing in the world. But nevertheless, looks awesome. I'm super stoked about how this thing might turn out. Imagine a lovely vintage looking tack doing za, 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 za. All right, dudeles, second half of today's program, now that the gauges are sorted out, is I've had this giant pile of aluminum, $500 worth of aluminum, sent from Send Cut Send for months now. It is 1/8 inch 6061 aluminum, and as you all know, I'm not a very good welder TIG wise, but that's where my fancy new welder from Harbor Freight comes in. It has this bad boy. So this is an aluminum spool gun that fixes to this multi-process welder, the OmniPro 220, that I'm a huge fan of. Now that my MIG welds are getting fantastic. In fact, you should see this cart right here. The welds are like, mwah. And I've actually done some great TIGging with it on steel. However, AC TIG isn't that great. So I got this aluminum spool gun, and I have a ton of these little aluminum, what are called coupons. And what I want to do here is dial in the process of, you know, just welding with this thing. And if I get it down, I've got this cool little jig from Harbor Freight that allows you to sort of set them up and weld them together and tack them. So the move is, can I get good enough with this little spool gun to tack a tank together? And I don't know. That's the big question, is I don't know if I will actually be able to do it. What I want to do is work out the settings on the spool gun on these little coupons and see if I can get my mojo. See if I can tack some together like in the corners. And if it works, then I will move my way into the fancy stuff. Thankfully, I have 2 entire sets of aluminum to use in case I completely blow it. And then I can just give it to somebody who knows how to TIG weld and be like, can you put this together? Because I'm failing miserably at it. So this thing is really cool. It's got a, by name, it's got a spool of aluminum inside the gun. And you just use it like a MIG welder. You know, it's just got like a basic MIG welder tip. You hit the gun and you fire it up. I actually used one of these from another manufacturer at SEMA a couple years ago and laid down some really nice welds. So my hope is, can I get good enough with this thing that I can put a couple of these coupons together like in a corner? Can I weld these corners together so it looks good? Because if it does, then I totally can put one of these bad boys together. So we're gonna give it a go. Let's go. Now the best part about this welder is once you fire it up, you basically have to tell it like how thick your wire is and then how thick your material is, and it does everything else for you. Like it totally does all the settings you need for optimal welding. To me, a lot of the mystery of welding is just getting your settings right on the gun itself. And since this thing does it for you, you're in a much better spot. Don't mind that last one. Ooh. Check that out. Now check that out. But that was really good. Man, I could totally live with that. Now I gotta figure out how to do it on the outside and not the inside. All right, I'm gonna try a different orientation here and see if it's better. I'm gonna go in this direction. Ooh, I was doing so well. Man, the first half of that is friggin' money. So good. So I wonder if this means I can only go in 2-inch bursts before it gets overheated, which is possible. But look how good that is. Look at that first part. Looks good. I mean, that I could totally live with that. And that goes right through. It's completely penetrating. That looks really good. Okay, sort of fixable. All right, I'm getting the hang of it, speed-wise. 2 more chances to do a corner. One thing to note so far is that when the aluminum is preheated, it really does flow a little nicer, and actually you have a bigger chance of burning through. So every time I do like the second weld, it really wants to start dipping underneath. So I think I've got to do these in relatively short bursts to make sure I keep a consistent bead, because the further you go, the more it wants to kind of dip down and punch through. But so far, so freaking good. Well guys, I figured something out. So what I did is I cranked up the wire speed and I cranked up the voltage and then gave it just a little zzz, and the tack welds it made are awesome. Let's see if you can see that one right there. It's nice and flat. I did another one here. I basically did all these corners. Now I don't feel confident enough to weld the entire thing up yet, but I do feel confident that I can try to assemble this thing with those same settings and tack it together at the very least, until someone who knows what they're doing with a TIG welder can help. So In the meantime, I have this really awesome piece of art. If you guys would like it, this would look really good on a mantle or perhaps a coffee table. Or if you smoke like huge cigars, you could put them there. Or if you have some sort of hot dog business where you'd like to store hot dogs for your customers, or you could deliver tacos on them. There's a lot of options for this. So I don't want you to be jealous of my welds. It's pretty easy to be, I get it. However, let's move on to the real deal here and see if I can tack a couple of pieces of oil tank together, shall we? All right, so here's what I've got. Right now, I've got these things set up. I'm using my little magnets here just to hold up these pieces of aluminum. And what I'm gonna do is I'm gonna butt this little corner up against it so they're completely square as much as I can. I'm gonna line these up so they look right. Then I'm gonna zap them. I'm gonna give a tack if all goes well in the world. And that will be the first corner of my oil tank. Let's go. All right, I'm hoping there's no reason why this aluminum doesn't act like that aluminum. And my settings can stay the same. And everything will work accordingly. Friggin' nerve-wracking. Take it out. Go. How do I do this? Okay, people, let's go. Okay. All right. Okay, magnets. Okay, spool gun. I'm hip to spool gun here. All right, dudes, check it. I did a quick little brush and 3M scrubby on the whole thing. It looks really good. There's like a couple little pieces of slag here. But literally the whole reason I got the spool gun was so that I could do this particular project. And you can see that the tacks look really good. Now, can somebody TIG this? I don't know the answer to that. But we're not done yet. There's a little like outrigger section on this tank that I'll show you guys right now. I'll show you what I'm talking about. All right, so for those of you who missed my original video on making this, this is the original Porsche oil tank. So this is actually where the oil on any 911 goes. It tucks up into the wheel well. So my idea originally was, let me modify this tank so that I can use it as my radiator, you know, my main coolant overflow tank. I don't love how it looks. And I thought, well, if I can recreate this in a more modern way out of aluminum, and then I'll use that as my radiator overflow, that would be great. So that's what this is gonna be. This is the original tank. I then made a cardboard version of it, which looks like this. I sent all of these dimensions over to our sponsor, Send Cut Send, and then got the aluminum back. So we're just assembling the aluminum right now, and it should, in theory, fit like the factory oil tank. All right. Great ball. So I just did what I think is a fairly smart move, and it was just in time. Before I scribe and cut this thing, I'm actually going to fit the tank up to the car and see if where this thing wants to be is where I want it to be, because the car might want it to be somewhere else. So I'm going to bring Sharpie down there and make sure that the orientation that I would like is the orientation that the car would also like. You are looking at the face of a relieved man. I'm so glad I just did that, because where I was going to cut this thing would not have worked. I would have interfered with my engine cradle mounting. So I'm so glad that I decided to do what I just did. And now I can scribe this thing and cut it. The downside, a little bit, is I was hoping to get away with sharing 2 walls, so I didn't have to cut like 3 different spots, but I can't. So now I'm going to move this here. All right, so that went well. We are in the final stages here, and I'm going to sand this thing down a little bit. Okay, dudes, I'm appropriately sanded and ready to weld this sucker on. Okay, Harbor Freight Spool Gun. What's up, Harbor Freight Spool Gun? Let's go. Yeah, man. Awesome. Look what I made. Will you guys look what I made? So, this thing obviously has to be fully welded up everywhere, and I'm going to hopefully be able to get somebody who knows more about TIG welding than I do to finish it. And then of course we've got bungs to put in for the input and output of the coolant. I don't know if I can get like a coolant temperature gauge in here. I've got to put the throat, the neck, which is going to be obviously aluminum for the radiator, but like, I am thrilled. I am completely and utterly thrilled that this thing turned out the way it did. I think it looks great. Thank you so much to Send Cut Send for all the pieces. And huge thanks to Harbor Freight for the Omni Pro 220 welder, which does MIG, it does spool gun, it does TIG. It doesn't do aluminum TIG that great. That's why I'm not fully welding this thing with it. Not that I can weld aluminum anyway, but you know what I'm trying to say. But yeah, man, I couldn't be more thrilled. I think this thing is awesome. It's really cool to go from like oil tank to cardboard mock-up to now it in aluminum. So that was huge. And that is going to be it for today's show. I hope you enjoyed the custom LED gauges and the process here of me learning this really cool spool gun for my Omni Pro. And that's it, you guys. You guys keep on rocking. We'll talk to you very soon. Thank you for watching.